We have a problem, a 40 billion ton a year problem, carbon emissions. The majority of these carbon emissions come from the way we make products and the manufacturing methods we use. And as an industrial design student at Central St. Martin's, I couldn't help myself but wonder, can I use industrial design as a catalyst to help decarbonize the atmosphere through the process of making products? We've been emitting close to 40 billion tons of CO2 every year ever since the Industrial Revolution. In order to stay below the 2 degrees or even possibly 1.5 degrees of average rise in temperature, we'll have to stop emitting carbon by 2050 and start removing at least 2 to 10 billion tons of CO2 from the atmosphere for the rest of the century. And that means you can't stay carbon neutral. You need to get carbon negative. In the present, if you want to qualify as a carbon neutral business, there are 3 criteria that you can qualify for: Scope 1, 2, and 3. Scope 3 includes all indirect emissions throughout the value chain. How your employees come to work, how your raw materials shipped, how it's shipped after, the food you eat, the public transport you use to come to work. And that's really what you need to strive for. In order to have a benchmark of study to compare before and after results, I would like to choose a mechanical keyboard and a screwdriver kit, 2 products that I'm extremely passionate about. A screwdriver kit and a mechanical keyboard. Let's dissect them and see what we can learn from them. This is a modular keyboard, so it has hot swappable keys, so that's a good thing. Unfortunately, the bottom chassis has the battery glued in and it does not have pull tabs to even replace the battery. So I assume that you're going to be damaging the battery when you replace it. And it's got a galvanized steel sheet that is reinforced to add for stability to the chassis. But also these have melted studs that hold it in place, so it's permanently glued in, and if you pull it out, you're going to break it apart. The PCB is the same size as the keyboard, which is the most difficult part to recycle. There are 109 keys, and once you take a closer look at them, each key has 7 components in it, and all 7 are actually made of different materials. 2 components being metal, that's the spring steel, and the spring leaf that acts as the contact and actuator. Now, the spring leaves are 2 components, but then over molded onto the base of the key to add for hot swappable feature, I would say. That would make it extremely difficult to recycle or separate during recycling. The key caps itself are made of a translucent polymer, but have an opaque paint applied onto them with a letter mask that allows for light to pass through. Now this again is extremely difficult to separate during recycling. These are parts where I can improve, but stick to the modularity. Now in terms of the screwdriver, shocker, a device that is meant to foster right to repair, actually needs right to repair implemented even better. But there's no way I can dismantle this without the use of a workshop or advanced tools, and I'm afraid that if I have to dissect this, I might end up breaking it. The rubber grips on the wearer handle are overmolded over polycarbonate. It does seem to come off quite easily from the polycarbonate body, so it might be easily recyclable in-house by wearer. What we can improve is definitely disassembly and monomateriality for recycling. Let's see how we could use design decisions as a tool to reduce a product's carbon footprint throughout its lifespan. What's important here is once you make these products carbon negative, you also need to make sure they remain carbon negative throughout its end of life cycle. And that's where design comes in. Now, in order to make a product carbon negative, you first need a base material that has observed atmospheric carbon at a molecular level. And it's during my research that I came across this company called Made of Air in Germany. And I had a great opportunity to talk to the CTO of Made of Air, Mr. Daniel. And here's what he has to say about it.
Yeah, my name's Daniel. I'm the co-founder and CTO. 2016, Made of Air was founded, and then in the early research, we were just looking for materials that had the potential to be carbon negative, and found biochar, utilizing the 2 outcomes of pyrolysis, which is an oversupply of energy, and char, which is a quasi-elemental form of carbon. And basically then taking the biomass, taking pyrolysis to disassemble it and reassemble it into products that were industrial and had performance. We have to make sure that the carbon is not only taken out of the air, but also stays out of the air. A biopolymer PrimeFlex, we are at, I would say, carbon parity, you could say. So for each kilogram of material that we produce, we are sequestering 1 kilogram of CO2.
And they were kind enough to send some injection moldable pellets that are carbon negative by 1:1. Let me show you. Wow. Black gold. Shocker, a ton of steel produces 2.5 tons of CO2. And through my research, I came across the Swedish steel manufacturing startup called H2 Green Steel. And I was given the opportunity to talk to the vice president of DRI plants at H2 Green Steel. Let's see what he has to say about it.
What we are trying to do in H2GS is we are trying to replace natural gas in the DRI plants with hydrogen. What happens is when you put up hydrogen in a DRI furnace, iron oxide is Fe2O3. When we put hydrogen, it is inserted at a very high temperature. Oxygen and hydrogen, it reacts and it is converted into water, whereas the Fe is taken out as a form of cold DRI. Yeah, basically in the other DRI plants, it was kind of a CH4. So we were producing from Fe2O3. If you add with CO, for example, they take out oxygen and it becomes CO2.
Finally, carbon neutral steel. You'd be surprised to know that 70% of a product's carbon emissions does not come when it's actually manufactured, but comes when it's used. Take cars, for example. The amount of CO2 emitted during a car's production is far less than the amount of CO2 a car emits throughout its lifespan, and that includes recycling. And as a designer, the choices you make today while designing these products and how they're manufactured affect them in long term in terms of making it easier to repair, easier to recycle, modular. Through my research, I got to talk to Matthew Harrison, the head of strategies at Seymour Powell, and he was part of this team that was responsible for designing the Fairphone. The Fairphone is a token for right to repair. It was designed from the scratch to be user repairable. Now, the discussions I had with Matthew was immensely insightful in terms of showcasing and demonstrating what requires to enable right to repair. Right? But repairability is just one facet that you can apply in terms of an ethical design principle. What I'm most excited about is applying a principle called circular economy, which encompasses many more principles under it. I had an opportunity to talk to the co-founder of the Agency of Design, Matthew Laws. They worked on an amazing project in-house called the Circular Economy Light Bulb.
We did this project actually quite a while ago, but we felt with LEDs, it's not a simple thing. You've got a circuit board in there, you've got one or many LEDs. LEDs need managing, so if they get too hot, their lifetime drops. So you can actually saw that if you increase the temperature, it decreases the lifetime of the LED. If you're going to make an LED bulb, you should look after the elements in there by managing the heat and also managing what happens to the product at the end of life.
Efficient energy management. Let's take a MacBook, for example, something I love and use every day. CNC machine from a single block of aluminum. Let's take it apart. I love this. It's so beautiful. The problem is, while creating space inside the chassis for all of these components, the byproduct of that is removal of about 70% of the material that was inside. And that's a lot of energy waste. The reason that's a problem is that when you're making a carbon negative or a carbon neutral product, the only supply source of energy that you could use has to be carbon neutral, which is already expensive and scarce. But there are manufacturing processes that are far more efficient in terms of energy usage. 3D printing is one of them. SLS, SLM, or even electron beam melting. These are manufacturing methods that use a lot less energy, and precisely they just use the energy required to process a specific geometry and to not create waste that needs to be recycled over and over and over. During the end of my research phase, after prolonged conversations and interactions with my MA course leader, Dr. Mac Malpus, and my BA design professor, Mr. Sudhakar Damodar Swami, I had a strong intuition that all of these ethical principles and the learnings I've gone through come under an overarching umbrella loosely defined as material banking. Now, full disclaimer, material banking is already a term, but it's loosely defined, and this is what I would like my definition of material banking to be. Well, first and foremost, material banking calls for the stop of sales of goods from all manufacturers, but from shifting from a sales model to a service model. This incentivizes companies to design their products for better repairability and recyclability. Secondly, since the products are sold through a service model and not an ownership model, this incentivizes the companies to not have the need to release a new product every year just for a constant revenue flow. The service model already does that. This stops from a lot of waste and a lot of products ending up in landfills. Now, this allows you to have a well integrated material traceability workflow within your organization, having account for the amount of material that's performing for you, the amount of material in the recycling pile, the amount of material in the manufacturing line. And henceforth, this makes you independent of raw material supply chains. And you're never going to pay for materials ever again. This would also consequently make your products more cheaper because you're not buying materials off the market over and over and over. And this also makes you one of the largest asset holders, possibly. One of the main objectives of this version of material banking is to help businesses realize their ethical design goals without being penalized as a business. Consumerism needs to exist for a steady economy. You can't just hope that stopping yourself from buying products will help mitigate the climate issue. You still need jobs. Companies have to pay you, and in order to do that, people need to consume their products and services. What I'm trying to say is the answer to climate change has to be a financially viable one. I think we are finally at a point in our journey where we could go off and redesign the selected objects with all the learnings that we've had from the industry experts, the papers, and all the research. So, yeah, let's crack on. After prolonged hours of material research, 120 prototypes, painful hours of testing, we finally managed to make a mechanical keyboard and a screwdriver kit that are both carbon negative. Here they are in their flesh, a carbon negative mechanical keyboard and a screwdriver kit. Ooh. Primarily, both of these products use PrimeFlex as their base material, which is carbon negative by 1:1. But they also have electrical components, electronic components, and steel components. And I think in the design, the visual aesthetic of these products are mostly informed by the honesty of the materials. What I've done is leveraged one material to achieve springy, translucency, and rigid properties. And by far, that was the most challenging part of the keyboard, more than the mechanism or anything else. And the reason the keyboard has this huge actuation zone in the front is from me trying to reduce the size of the PCB. And that allowed me to reduce the PCB size quite significantly, I'd say about 60%. And that's an important thing that I had to do because the PCB is the most difficult part to recycle. Now in terms of assembly, there's no glue and no screws. It's all held in friction and geometry features. Now the screwdriver kit, on the other hand, is designed from the ground up to be a sculpture, a showcase, or a statement piece for right to repair. The modularity is informed by my past experiences in buying tools where I was forced to buy an entire screw kit just because I need a couple bits from them. And so I thought, why don't I design a modular system where the bit arsenal grows with the user as they encounter new situations where they need new bits. And they're more informed by the bits they need, they make more informed choices. And this reduces the amount of energy required to make a kit and the energy wasted. Now in the screwdriver, one of the design decisions that I'm most proud of is not having an overmolded rubber grip or a knurled pattern grip. Instead, what I've gone for is implementation of a groove that doubles as a graphic pattern and helps divide the handle into sections that collapse to the grip of your palm and provide an immensely good grip. Right now, it's important that we present these redesigned products to an industry expert who has a career in sustainability to validate our claims and learning and see if we're on the right track. All right. Hi Jane, thank you for coming. Yes, I'm not very happy with the packaging. Yeah.
Oh, and this is the mechanical keyboard.
That's the mechanical keyboard.
Whoa.
So one of the things that I had to do was every key in a mechanical keyboard has 7 components, the ones I've opened apart, and all 7 components per key are made of different materials.
Wow.
So you can't put, it's not mono material.
Yeah.
So
Wow.
it's all held by friction and there's no glue or screws in it.
Wow.
And
Amazing.
so you can just pull these tabs out and repair.
Yeah.
And what's holding all of this in place, there are 7 stainless steel rods.
Oh yeah.
And if you push them out, the
Yeah.
entire thing disassembles.
Yeah, you just
I've not overmolded a grip or used nulled patterns.
Yeah, good.
So I just use the graphic elements grooves here,
Nice.
reuse that.
Yeah.
That collapses and divides the handle into sections and it really forms the
So
handle.
yeah, you really just so
you
that's
tried it,
great.
yeah,
It's
yeah,
absolutely
yeah,
great. It's
yeah.
so clever. Well done. Really, really good. Yeah. Wow, this is brilliant.
So
Cool.
just in terms of design, I'm trying to showcase what design can contribute to the solution apart from just materials. Yeah.
Totally. And exactly. It does show that not only I understand the argument you used around the the screwdriver being the tool that allows you to extend the life of things by repairing, but you've also then overcome all the problems within the tool itself. So that's brilliant. Yeah. We'll have to use this as a little example case study for the undergraduate students.
Well, love
great.
it. Yeah.
You'll have to share that because I think for them to see that it's possible if you rethink certain things and that we really need to look at different materials
and really leverage the power of design here.
Yeah, exactly.
Yeah. Overall, the keyboard has resulted in a product that's about 750 grams carbon negative and a screwdriver kit which is 180 grams carbon negative. It's not carbon neutral, but it's carbon negative. Now to put this into perspective, Apple sold over 250 million iPhones last year. Now if every iPhone was just 60 grams carbon negative, that would have led to 13.5 million tons of CO2 being removed from the atmosphere just last year alone. And that, my friends, is economy of scale. And that's why small actions have a large impact. In the end, what I've learned through this journey is that as an industry designer, the choices I make and how my products are designed and manufactured have climate altering consequences. And this affects everybody, but mostly the people who make up my daily life. And the worst part is, they don't see it coming. This could be the doner kebab guy, the barber who makes me look good, or the violinist who plays at the subway. And that's too much power for any one person to have. And we all know with great power comes great responsibility. And I hope we take things seriously and practice industrial design with great rigor. Thank you. It's the small things in life that inspire us to take big decisions that have a meaningful impact. And I would love to share what inspired me to go on this journey to find answers to the question, can we make a product carbon negative? My inspiration to embark upon this journey sparked during the ceramics workshop held at the banks of River Thames. Our guide asked us to collect artifacts from the banks that were made of broken or chipped ceramic tiles, kitchenware, or cow bones. And at the end of the workshop, we gathered around to discuss what we've collected. From all the artifacts, nothing seemed to catch our guide's attention as much as this one thing did. A piece of tile that had a hole punched in it only halfway in when it was meant to be punched all the way through. It was this piece that he described as he was holding a piece of history that encompassed an individual's mistake born out of his laziness 300 years ago. And this moment led to a profound reminder that the mistakes I make as an industrial designer today, if not reversible, will have dire consequences for future generations. And this inspired me to practice industrial design ethically and me choosing to have a negative carbon footprint.